Hello, this is Jonathan Inglesma. In this lecture, we're going to talk about iOS table view controllers and navigation controllers. We're first going to look at a few more details about the responsibility of view controllers. Then we'll look at navigation controllers, table views, and in table views we'll look at both how to construct a table view that gets its data that has static data, in other words, data that doesn't change. And then we'll show you another example of dynamic table views. And we'll actually load the table based on the photo albums in your photo roll on your device. So we've seen previously that view controllers are the glue between our models and our views. And so that's kind of from a looking inward perspective. Within each MVC triad, the controller is controlling or managing its model and its views. However, in addition to this task, view controllers also communicate and coordinate with other view controllers whenever UI transitions occur within the app. For example, when a controller or when we transition from one screen to the other, it's actually the view controllers that interact together to make that happen. And so from a looking outward perspective, the view controllers actually get involved with more than just the particular view that they happen to be managing. Now it turns out when we're building apps using storyboards that a lot of this is done for us under the hood. In other words, this type of looking outward, quite a bit of that, at least in terms of how we get from one screen to the other, is done by segues in the storyboard. Nevertheless, there is some code that we end up writing as well to handle these segues. Other things that the view controller is responsible for is it's responsible for making sure that the view itself gets loaded into the interface. And interesting, this is usually not the managing view controller, but some other view controller that does that. The animations that appear, or the animations that occur when views appear and disappear, are also managed by the view controller. Again, a lot of that is done for us automatically in the base classes, but if we wanted to override and change that, we can as well. And then finally, view controllers work together to save and restore the state of the model that they're managing. And this, of course, allows the app to restart if it's either terminated explicitly by the user in the task manager, or perhaps put into the background when another app runs or the user hits the home key. In terms of managing the data, and we'll be doing this via the view controller code, unless we have a self-contained destination view controller, all references to the data that your controller is managing should come from the source view controller. And what we mean by the source view controller here is the controller that actually started up the current controller, or cause the segue to happen. We want to use Interface Builder for this as much as possible, and we'll always use a delegate pattern when we want to have communication back. In other words, when a view controller is invoked by another view controller, then that destination view controller really shouldn't know the type or the details of the source view controller. Instead, it can define a protocol, and then it can delegate out that protocol to the view controller that's calling it. In other words, the invoking view controller here would implement that protocol so that eventually when the destination view controller wants to communicate something or some event back to the source controller, it would just call that delegate method. And that's, of course, to minimize dependency in our code. So in general, we want to avoid any unnecessary connections to objects that are external to our view controller. Now, the view controller that manages the view at the top of the view hierarchy is what we refer to as the root view controller. And it's responsible for a number of things. First of all, it's responsible for handling the rotation of the user interface, and that's something we'll be looking at in the next lecture. It manipulates the status bar. It determines whether or not that status bar is present or not, as well as its styling. There's a light or a dark styling of that. There's only one root view controller in our application. Now, there are these subordinate relationships. In other words, apps consist of many view controllers that can be subordinate to that root view controller. And these subordinate relationships come in two flavors. There's parentage or containment, when one view controller contains 0 or more other controllers. And there's also this subordinate relationship referred to nowadays as presentation. Formerly that was known as modal views. So in the parentage flavor, we have a view controller that acts as a parent, and it may contain a subordinate view controller, which we refer to as the child. A child view controller's view, if it's visible at all, is typically a subview of the parent's view. And so the parent view controller makes the views of its children visible, or even can replace one of its children's views that's up on the screen with another one of its children's views. That brings us to navigation controllers. They actually exhibit this parentage subordinate relationship that we're talking about. In particular, navigation controllers manage a stack of view controllers. And this is a convenient interface when we want to have a drill down type interface and we're working with hierarchical content. So we have a list of things and we want to see the detail of one individual item in that. We'll often use navigation controllers for this. So each view controller that's in that stack manages a distinct view. And the navigation controller itself navigates among that stack of view controllers. So I can push more children on, and then I can start backing off and exposing other child controllers. So one of the children controllers at a time is shown. So conceptually, if you're an iPhone user, you're very well familiar with this navigation controller concept. So over on the left side, you see the iOS settings application that's on your phone, and it's a table view. It's just a list, but it's got a nav bar on the top, so it's actually a UI navigation controller that's controlling these screens. And so if I were to go and select the item Safari, and you see that little disclosure indicator on the far right of the cells or the rows, and that indicates there's something over to the right, you would see a transition to the screen on the right. In fact, it would be animated, so that screen on the right would come in from the right, and it would kind of push the screen on the left off the screen toward the left. And at the same time, notice that little blue settings button in the upper left of the drill down screen here. That gets placed up there automatically by the navigation controller. In fact, the wording settings is coming from the title on the previous screens. And if you're an iPhone user, you know that's essentially your back button. So when I push that, it literally pops the Safari settings screen off the stack and transitions me and makes that settings screen visible once again to the end user. Now the navigation controller, here's kind of a dissection of it, and you can find the link and more detailed discussion of this on the bottom of the screen. So this comes right out of the Apple documentation. But basically the white box in the middle is where our custom, so our view controller that we're actually embedding into the navigation controller gets shown there. So part of the screen is actually being filled by the view hierarchy that we provide in our custom view controller that's embedded in that navigation controller. Notice on the top of the navigation controller there's a navigation bar, and that is actually managed by the navigation controller. And we can also have a navigation toolbar on the bottom of the screen. If we want to look at this from more of a software perspective, that stack of view controllers is basically a LIFO collection of view controllers. So it's like a real stack. So last in, first out. And the first item added to the stack is often known as the root view controller. It's the root. So how can we put one of our custom view controllers into or embed it into a UI navigation controller? So there's multiple ways. One simple way to do it using Interface Builder is if we're in a storyboard, you can simply go to the lower right of the screen and drag a UI navigation controller up from the library palette and just drop it onto the canvas. By default, it's actually going to be hooked up to a table view because that's the most common way. So if you don't want it in a table view, you might need to delete that. But once you've got a single UI navigation controller on the screen, then you can select it, control-click, drag from that nav controller to the root view controller, whichever view controller you want to add. And then when you release it, you're going to select the root view on that little pop-up menus. Now, in subsequent segues, you're going to make sure the type of that segue is set to push. Actually, this slide needs to be updated because as of iOS 8, Apple has abstracted these segues. And so that segue now is just going to be a generic type, and it knows if the segue is happening in the context of a navigation view controller, it will do a push, and if it's a presented view controller, then it will actually do a modal type segue. So that kind of happens automatically now for us. That brings us to that presentation relationship, so the second type of subordinate relationship that we mentioned a few moments ago. So in this situation, the view controller, which we're going to refer to as the presenting view controller, can present another view controller, which is referred to as the presented view controller. Now, the presented view controller in this case is not really a child like it was in the navigation example that we looked at a moment ago. So in this case, the presented view controller's view will cover part or all of the presenting view controller's view. Now, this was formally known prior to iOS 5 as a modal view controller. And it comes from the same type of modal views that you might be used to on a desktop computer, where a window comes up and you have to either dismiss it, do something, or dismiss it, and nothing else can really happen until you do that. So table views in iOS are probably one of the most commonly used view controllers out of the stock view controllers that the iOS frameworks provide us. They have many purposes. We use table views whenever we want to let the users navigate through hierarchically structured data. Or if we have a indexed list of items, the contact apps, for example, on your iPhone is an example of a table view. Or if you want to display detailed information and controls in a visually distinct grouping, so we can kind of control the cosmetics of how that table actually looks. Or sometimes we'll use table views when we want to give the user a set of selectable options, something where they can turn on certain options and turn off others. So we have multiple vertical rows in a UI table view, but only a single column. So it's not really like a spreadsheet like we're thinking. So it's really just a vertical set of rows with a single column, although we can put all kinds of sophisticated things within that column. Table views can be static, getting their data from some fixed information source, or they can be dynamic, determined at runtime. It automatically inherits from the UI scroll view, which means if we have more items in the table than fit on the screen, then it has the scrolling behavior for us automatically. We don't have to program that. We customize our UI table view by having our controller implement the data source and the delegate protocols. Now, there's lots of different prefabricated layouts for the individual cells that we're going to use in our UI table view. First, some different styles of table views. So here on the left, you see the dynamic / plain index list. So there's not a lot of detail in the individual rows, but you do see headers over them. So this is actually the contact app on your iPhone. And notice also you have that index down the side, an alphabetical index. So you could very quickly drill in on, based on the last name. In the center screenshot, you see the static default layout. So this is actually the settings application. And then the custom layout is the last one. This is coming from the photo apps. In this case, each row can have one or more photos, and there's some interesting headers there. There's a share button on each one of those, and so forth. Those are actually photos from our photo roll displayed in a table view fashion. So this is the grouped style. And you'll notice here in our group style that we have a section, so a grouping of rows that has the row data, but also are set off visually from the rest with a header and a footer. So the rows themselves, the data, we call those cells. So that's our table cells. And there's the header, the footer, and there's also these disclosure indicators that I mentioned a few minutes ago. And they basically indicate that we can navigate to a new screen. And often that means we're going to drill down into the details of whatever that row represents on the screen. Here's the same style, only in an ungrouped style. And in terms of those cell styles, here they are. You can see the various cell styles, and these layouts are done automatically. We can just select them in code and populate the various attributes of that cell, and we get this layout without doing any kind of customization at all. So most of the time, we're going to manage UI table views with UITableViewControllers. This built-in UITableViewController has all kinds of default behavior that's going to be useful for us. And normally the UI table view fills the entire screen, screen real estate that's available. But it doesn't have to. You could have a table view, for example, that just fills a portion of the screen. And since the UI table view paradigm involves selecting a row and zooming in on the details, we need some kind of way to navigate from that detailed view into the detailed view, and then of course back again to the original table view. And so this is normally done with Navigation Controller. So we use UINavigationController in concert with the UITableViewController. So in our next video, we'll take a look at constructing a simple static table view demo, and we'll do this. We'll basically create an application that puts up a table view using fixed static data.